And our last lesson of this chapter is on scatter plots at the Tier 3 level. The table shows the population of a state and the number of licensed drivers in millions. Use your calculator to make a scatter plot. Is the linear model appropriate? So we're going to make a scatter plot. So looking at my scatter plot, this linear model is appropriate because you can see that it looks like it's increasing. There's no sort of weird shapes. So write the equation of the line of best fit. So I'm going to use my calculator. So instead of using x and y, I used population and drivers because we made population x and drivers y. I can do that and interpret the slope, so 0.62. So as population increases by 1 million, number of drivers increases by 0.62. And that's 0.62 million. Interpret the y-intercept. We haven't done this before, but it's not that hard. We know the y-intercept means that x equals 0. At a state with a population of 0, there will be a predicted 0.42 million drivers. Now, that doesn't make much sense in this situation because we don't have a state with 0 million people. But what this is showing is that there is some error because if there was a state with 0 for our population, there should be 0 drivers. So what that is telling us is that these might be kind of high estimates. A lot of times we interpret y-intercept as the starting value. Well, there is no starting value in this case. Statistics is like that a lot, where we have an intercept that doesn't fit a real-life situation, which is kind of cool, I think. The population of Michigan is about 10 million. Use your line of best fit to predict how many licensed drivers there are. So we could say the number of drivers equals 0.62 times 10, right? That's our population in millions, plus 0.42. So 6.62 million drivers. How strong is the correlation? So correlation coefficient R, and is it close to 1 or -1? So how strong is the correlation? Let's look at the graph. So if we look back at our graph, that line fits very, very, very nicely. If our dots were far away like this, and that would be bad correlation. So this is very good. So when we go to do this, I'm going to add a calculator page. We're going to go to Menu, Statistics, Stat Calculations, Linear Regression mx plus b. Remember, we had population for x and drivers for y. And this is where we get that R. See how R is 0.998? That's very, very, very close to 1. So that is extremely strong correlation, right? We saw that from our graph. Those points really, really, really were close to forming a line. If the points don't really form a line, then we're going to be close to 0. -1 would be a very, very strong correlation that is negative. So for example, that would be about a 0 correlation because it's not really going up or down and doesn't form a great line. This would be a strong negative correlation. The line is going down and the points form a very clear line. So this would be a R of -1.